We tend to think of the sky as just, well, empty space above our heads, right? But what if it's not? What if it's actually a huge invisible ecosystem? Today, we're diving into a really wild hypothesis, MMCAP. It's this idea that when everything's just right, clouds of living microbes could actually organize themselves and maybe, just maybe, start to glow. So, this whole idea kicks off with a real-life scientific mystery. Back in 2019, a satellite flying over the island of Java picked up something incredible. It saw this massive, steady glow out in the ocean. And this wasn't city lights, or a big fishing fleet. Nope. This was something totally different, glowing all on its own in the dead of night. And we're not talking about some little patch of light here. This thing was massive. A huge, stable field of light that you could actually see from space. To put that into perspective for you, we're talking about an area bigger than the entire country of Iceland. Just glowing. Out in the middle of the ocean. Wild.
So the big question is, what on earth was it? Well, scientists looked at everything. It wasn't pollution, wasn't ships. They ruled out all the usual suspects and landed on something incredible. Living, glowing bacteria. It turns out this was a Milky Sea, and that's a real proven thing. It's where gazillions of microbes get together and create a glow so bright you can see it from orbit. And that's the key idea to hang on to here. Life, actual living things, can create light on a massive planetary scale.
So, oceans that glow. I mean, that discovery really leads to a fascinating question, doesn't it? If life can pull this off in the water, what might it be doing up there, in the air? Okay, so here's the core idea laid out side by side. On one hand, you've got Milky Seas. That's the stuff in the ocean, a proven fact. We know microbial groups can create these huge, stable light fields. But on the other hand, you've got this new hypothesis, the aerial version, MMCAP. This is the theory that maybe airborne microbes could create their own glowing domains. Not stable like in the sea, but more like temporary, fleeting flashes of light. And yeah, this wild idea has a pretty serious-sounding name. Scientists are calling it MMCAP, which stands for Macro Microbial Coherent Aerial Phenomena. It's a bit of a mouthful, I know, but it actually breaks down really simply. Macro means big, microbial for the tiny life forms involved, and coherent aerial phenomena just means some kind of organized event happening up in the air. So how would you even make one of these living clouds? Well, think of it like a recipe. Scientists have figured out the 3 key ingredients you'd need for an MMCAPHP to form. Okay, first up, bioaerosols. You might not have heard that term, but the air is literally teeming with them. They're just tiny biological particles. Think bacteria, spores, little cells just hitching a ride on dust grains. And the amazing part is they can stay alive while they're floating around up there. It's like an invisible ecosystem all around us. So here's the 3-step recipe. Step 1. You need a lot of those bioaerosols packed together. Step 2, you need high humidity. We're talking 70% or more to keep the microbes happy and active. And step 3, you need an electric field in the atmosphere. The theory is this helps line everything up. You get those 3 things together, and you might just have the perfect conditions for an MMCIP to spark to life. All right, next up, the MMCAP fingerprint. Okay, let's be real. If these things do exist, how would we ever know if we saw one? I mean, you can't exactly catch it in a net, right? So scientists have proposed looking for a very specific fingerprint, a combination of signals that, together, would be a dead giveaway. And this multi-signal signature has 4 key parts. First, you've got biophotons. That's the faint whitish glow itself. Second, a weird lingering haze that you could only detect with special lasers. Third, a strange whisper or a dip in very specific low-frequency radio bands. And finally, actual chemical traces, a spike in certain organic compounds that you could literally sniff out with air sampling equipment. Now, you're probably wondering, what exactly are biophotons? I mentioned them, but it's important to know what they are, because they're not what you might think. Okay, so get this. Biophotons are this ultra-weak light that all living things give off. And I mean all. You, me, the plants outside, we're all faintly glowing right now as part of our normal life processes. It's a fundamental, if super faint, sign of life. So an MMCAP would be the combined glow of billions of microbes, all their little life signs adding up to something we could actually detect. So, to make sure they're not just chasing ghosts, scientists have set a pretty high bar for evidence. For something to even be considered a candidate event, they need to spot at least 2 of those 4 signals happening at the exact same time. Not just 1, 2. It's that combination that makes it compelling and helps rule out other explanations. So, that leads us to the next big question. How do you hunt a ghost? I mean, how do you actually go out and find one of these things? Well, there's a whole scientific protocol for finding and, just as importantly, proving an MMCAP. The hunt begins by knowing when to look. You can't just stare at the sky 24/7. So researchers came up with something called the MMC index. Think of it like a forecast. It tracks those 3 key conditions: super high humidity, a lot of dust in the air, and an elevated electric field. When that index starts to spike, that's the signal that conditions are perfect and it's time to start the hunt. Now, a huge part of good science is playing detective and ruling out all the imposters. For example, if you see a night glow, could it just be smoke from a wildfire? Easy. Check the satellite fire data. What about those weird radio signals? Maybe it's just a distant thunderstorm. Okay, let's check the geostationary lightning mapper. It's all about this careful process of elimination.
But what's the ultimate test? The final confirmation? Well, you have to try and recreate it in the lab. The absolute holy grail here would be to build a mini MMCAP in an atmospheric chamber. You take all the ingredients, put them in a box, and see if you can make one from scratch. That would be the slam dunk.
Okay, let's zoom out a bit. Science in the sky. Why does any of this matter? I mean, why go through all this trouble to hunt for glowing clouds of bacteria? What's the big picture? This really gets to the heart of it. A quote that sums it up perfectly is this: "The air around us is not empty. It's a vast, invisible ecosystem, an aerial biome we are only just beginning to understand." It completely reframes how we think about the atmosphere. It's not just air and weather up there, it's life. And just to be super clear, the search for MCAP is not about finding aliens or UFOs. Not at all. This is a serious scientific hypothesis. It's about revealing the hidden, collective life that might be organizing right above our heads. The key word there is organizing. It suggests that life isn't just passively floating in the sky. It might be forming complex, temporary structures we never knew were possible. And that really leaves us with a final, mind-bending question to think about. If something like this, a secret symphony of life, could be playing out in a place we've always thought of as empty, what else are we missing? What other incredible biological processes are happening all around us, in places we've never even thought to look?